Hello everyone, welcome back to my channel. I hope everyone is doing great. Let's solve today's Leetcode problem 1200 minimum absolute difference. Given an array of distinct integers array, find all pair of elements with the minimum absolute difference of any two elements. Return a list of pairs in ascending order. Each pair AB follows A, B are from array A less than B, B minus A equal to the minimum absolute difference of any two elements in the array. Okay, we have to identify pairs such that their difference is actually equal to the minimum absolute difference of any two elements in the array. Okay, so let's take this example. Okay, if you see 1 minus 2, the difference is 2, and this is the least difference which we can obtain by choosing any two numbers from the given array. Okay, if you choose 4 2, which the difference is 2, but we want the minimum absolute difference, so can we choose 4 1? No, the difference is 3, still we cannot choose this. 4 3, difference is 1. Yes, we can choose these two numbers, and we can say that this is the minimum difference. Okay, if you can also choose 2 1 1 2 3, those pairs also result to the minimum absolute difference. So though among all possible pairs from this given array, the minimum absolute difference is of any two numbers is 1, right? So we have to identify all the pairs whose difference is 1 now. Now 1 2 is one such pair, 2 3 is one such pair, 3 4 is also one such pair. Okay, so how can we obtain this? Okay, so if we have all, let's go back to the Excalibur. Okay, so let's say these are the numbers we have. Okay, so difference between two numbers will be always less if they are adjacent numbers in a sorted form. Okay, so if let's say we have 2 4 5 6 and 8. Okay, so the difference between these two is definitely lesser than the difference between 2 and 6, right? Difference between 2 4 is always lesser than the difference between 2 and 6, right? Also difference between 4 6 is always lesser than the difference between 4 and 8. So idea is to have the array in a sorted form and get the difference between the adjacent numbers. Okay, so this is a given array, let's sort it. And what is the minimum difference which we can obtain? Minimum difference which we can obtain is the minimum of the difference between all the adjacent pairs. Okay, so the minimum of 1 comma 2, minimum of the minimum of difference of 1 comma 2, minimum of difference of, so it is basically the minimum of 2 minus 1, 3 minus 2, 4 minus 3. So whatever is the minimum which we obtain here, that is the minimum difference which we can obtain. Okay, so the minimum difference will be 1. This will be turned out to be 1, right? So now that we know the minimum difference which we can obtain is 1, now we have to retrieve those pairs, right? So given this difference, we will just take all the adjacent pairs and then get the difference whose get the pair whose difference is actually equal to 1. Let's take another example. So let's say this input array, so let's say this input array will also contain 5, let's say 8. Okay, so the pairs which we can obtain is still the minimum difference is 1, but the pairs which we obtain is 1 comma 2, 2 comma 3, 3 comma 4 only, but 4 comma 8 is not a valid pair because its difference is 4 here. So we want all the pairs whose difference is equal to this minimum difference. Okay, right? So this is one approach. So where you will basically identify first what is the minimum difference, and then will basically iterate through all the adjacent pairs and then check whether the difference between the current pair is equal to the minimum difference. If yes, then we'll store it in the resultant array, or else we'll skip it, right? That is one approach. The second approach is to, instead of iterating twice from the given array, we'll iterate in a single go and populate the resultant array. Okay, so what I mean is basically we'll first sort the array and we'll keep of two things: what is the minimum difference so far, and what is the current difference of the adjacent numbers. Okay, so minimum difference in the initially it will be, we'll set it to the max integer dot max. Okay, so when I was checking the current difference. If the current difference, if it is greater than the minimum difference, then this is not a valid pair which I am looking for. So then I will skip it. But if the current pair difference, if it is equal to the minimum difference, that means it is one of my solution. Okay, then I will append that to my current solution. Okay, there is one more case where we have identified a difference of 2. Okay, the current difference is actually less than the minimum difference which we have identified so far. That means this is a brand new pair which is potential for our solution. So in this case, we will basically override the previous result and then we will generate. So I will just explain it with you an example, then it will be a lot more clear. Let's say I have 2, 4, 5, 6 and 7, 1. Okay, the second approach which I was saying is I will just iterate and then I will basically populate my resultant array. That is what I mentioned. So initially the minimum difference is basically integer dot max value, right? And first I will check these two pairs. Okay, what is the difference? Difference is 1. So difference is 2. So the current difference is actually lesser than the minimum difference. Okay, that means I have to override my minimum difference and I should also update my resultant array. Resultant array will be the new list with 2, 4 as a pair. Okay, so this is my result so far. Okay, now that I will go to the next pair which is 4, 5. What is the current difference? Current difference is 1, which is lesser than the minimum difference. So I have to override my minimum difference and I should also override my result with the new pair which is 4, 5. Okay, the moment we encounter a difference which is actually less than the minimum difference, in that case we have to override both minimum difference as well as the result. Okay, now we have a difference which is equal to 1, so I don't have to override any of these values, but I have to append my current pair to the result. Okay, what is the next pair? The next pair is 6, 7 whose difference is 1. Still that current difference is equal to the minimum difference, that means I have to just append my solution. The next is 7, instead of taking 7, 8, let's take it as 7, 9. Okay, now the difference is 2. Since the difference is greater than the minimum difference, I don't have to do anything, I should simply skip it. Okay, and let's say we have 10 over here, then I am processing these two, the difference is equal to the minimum difference, then I will basically add it to my result. Okay, I hope you understood this approach. Okay, I have implemented the second approach which is basically doing it in a single iteration. I will just show you the code as well. As I mentioned, we first have to sort the array. Okay, now that we have sorted array, I have a variable which will keep track of what is the minimum difference so far, which is initially it will be integer dot max value, and then I should have a variable result which will keep track of all the keep track of my pairs. Now I will just iterate through the adjacent pairs starting from index 1. Okay, the difference is basically the current difference, which is the current element minus its previous element. If the difference is equal to the minimum difference, that means it is a valid pair for me. Then I will append to my existing pair in a new list. If I identified a difference which is actually less than minimum difference, that means I have to override my result with a new list and then I have to append it, right? And then I should also update my minimum difference. Once this entire iteration is done, my result will contain all the pairs with minimum absolute difference. Let's just run this solution. As you can see, all the base test cases were passed. Let's try to submit this. As you can see, it has also satisfied all the test cases and it is pretty efficient and it has beaten most of the solutions. Okay, so before jumping dive into the time complexity analysis, I highly recommend you to subscribe to my coding channel so that you won't be missing the content I will be posting. Okay, so let's try to analyze the time complexity. As you can see, in the first step itself we are sorting the array. The sorting would actually take a time complexity of big O of n log n if merge sort is being used under the hood, and the space complexity is basically big O of n. Okay, so here if you see this, we should not keep track, we should not consider result into the space complexity, because this is what is necessary for us. Okay, now if you see the time complexity here, we're just iterating through the entire array, so this would be linear time. So the highest time complexity is actually the time complexity coming from the sorting algorithm, which is big of n log n, and the space complexity also coming from the sorting algorithm. Okay, so the overall time complexity and space complexity will be these. That's all about this problem. If you like the explanation, hit the like button and also subscribe to my coding channel. Do share your valuable feedback in the comment section. Thank you.